Hey everyone, with you Elena Litvinova. So in this video we will study trees. So in my previous YouTube history I already spoke and talk about binary trees, and in this video I will explain you a new algorithm about tree. So it's written like that, this word, so because the pronunciation is quite close. We will study how we can use them and how they can help us to save a huge amount of time in different tasks, which we programmers, software engineers can resolve in our working day. Yes, and in this video we will create an algorithm for this tree with JavaScript. So I'm a JavaScript engineer and we will try do this in JavaScript. And also we will discuss in which tasks it's very cool to use trees. Before, of course, not forget to subscribe on this channel, press bell icon for not missing other videos, and let's go. Let's speak about trees, for what we can use them. So this type of tree help us to create a tree where keys, different strings, for example usually symbols, and we can save words there and go inside looking for exactly word, and it can be highlighted as special key, so we have this key inside of our tree. And where we can use them, for example, it's very cool to create associative arrays, or for example autocomplete with different words, or also I used this type of trees for encoding and decoding different strings, and it was very helpful because, for example, you have a special string and replacement for that, and you need to understand, do we have replacement for example, we have a huge string and there are some symbols which we just need to replace, and we have associated array what we should to replace, so encoding and decoding. And this tree, it's also really awesome in this task and save us a huge amount of time so to work with algorithms. It's very important in our computer science technologies, and let's try to create our own algorithm on JavaScript so to understand it as better as it possible. Okay, first of all, we need to open, for example, any editor which you have. I have a VS Code, and here we just need to create, for example, a new folder, and we can create here just tree and open it here. Open folder, documents, tree. Here I just create a couple of files, index.js and index.html. I decided to start JavaScript using Google Chrome browser because in the console in this browser it's very cool to go deeply into the different objects, and we can see the structure much better. Basically we could use, for example, debugger from VS Code, but for me it's more comfortable to use just browser, as they have the best console ever. Here I just need to create a small HTML with, for example, head, where we just add title and, for example, tree. And here in the body we just add script with source to our index.js and like save this. And later we just need to check that everything works as good as it possible. And let's open our Chrome and open this with Chrome. We inspect and we open console and we see here, yeah, it works. So currently we can start with our algorithm. Okay, let's try. First of all, I will show you how these types of tree looks like. For example, let's create a comment, and we have several keys and we need to put into this tree. So we will create our tree like just an object, because everything in JavaScript is objects, primitives and objects. the two most important things in JavaScript, right? In JavaScript, keys are saved like just strings, and we have here to have the whole dictionary and, for example, ABC and etc. So we could have a lot of different keys, and inside of it we can go in other keys, so words, and somehow, somewhere we can say, for example, is value or something which is highlight exactly this key, what means that we have in this tree key like C. And here we say, for example, true, or any additional information. And the goal of this lesson to create a class which helps us to create this structure depend on different array of strings. And let's try it. We write class tree, and why it's class? Because later we will use very easy to create a lot of trees which we want to use everywhere. So it's like a factory. Yes, design pattern factory. We just create a class and use it everywhere where we can. And later what we have here, constructor, because every class has constructor. I will not put here any additional information, just this, insert and search. Just two methods I will add here. So insert helps us insert strings into the tree, and here search, and here additional information, so which we can pass. Okay, and this is class. Because of it we use a special word which is new, which help us to create independent objects inside of which we can use these. So special word, this is a link on this object inside, and we can manipulate with it. So basically when we create a constructor here, create an object this, it's basically just a simple object which has a prototype object and all properties which we save here. It is just hidden operation which is created. But yes, okay, continue. Now here we create a tree. So what we need to do, first of all, let's create current state, current keys. And this is this. We start with a global environment, this. We maybe could to create something additional, like maybe not this, right? Maybe because we could have here a lot of different methods and think around it. We could create this root, for example, and there go into our tree. But let's work with this. Okay, and current keys for, and we go through let key of Esther, and what we just go into the depths of our existing tree and look for symbols which we have, and we create like this. If current keys at key exist, so we just need to save a new keys is equal this and continue. If it doesn't exist, so we just create current keys is equal just empty object, and we do the same. And when we go through the whole loop like that, we will have a link on the last object here, and because of it we can use it and say, for example, additional information, and say, for example, is value is equal additional. For search, basically we use the same approach. We just need to go as deeply as it possible inside of this string, sorry, Esther, inside of this string, and later just return current keys is value, and if we have values there, so that's it. And later what just we can do, for example, create a dictionary and save it there. I prefer to create just a small dictionary like that. And we can add these words as a keys, and here is value information on current words. So we go through let value or key, key value of dictionary, and here we just we say my tree, insert key value, and later we just need console.log my tree, like that. And let's try to start. And what we have tree, which is object, and inside of it we have keys. Look at it. In the prototype we have insert, search, and all other methods. So here we maybe it would be cool to add additional check about it is direct method or not. So exclude the situation that here we find the key like insert, for example. But anyway, let's check. So we have HOT, so okay, hello, and testable. And hello we have, you see, just letters, we just go deeply into the object. And then last one we have hi, right? The same about okay, and the same about test. You see on test we have is value, but at the same time we continue our object and go deeper inside of it, so is value perfect, right? We created with you a tree, and how we can use it, for example, for autocomplete, how I said, so for looking the information exactly different words which we could have, right? And also for encoding, decoding different information. So for example, if you encode some string, you just go through this string and checks, do you have inside your tree exactly some symbols. It is quite fast algorithm because you just go through exactly needed letters and you not try to loop everything around it. Yeah, and so we build this algorithm. I hope it will helpful for you in different approaches, technologies, and in your daily code. And of course, not forget to subscribe on this channel, press bell icon, and see you in next video with viewer Elena Litvinova. Bye bye.